So just so you guys know, again, I'm screen recording and voice recording. So today we're going to talk about virtual machines, and the main focus is going to be on networking. So networking with virtual machines. And it seems like most of you guys have set up virtual machines before. Everybody has VirtualBox or VMware. So let's just go over some basic stuff. Actually, before we do that, why don't we go ahead and set up some of these virtual machines, just because it's going to take some time. So let's start with the SIFT. That's the SANS Investigative Forensic Toolkit. So double click that and your virtual machine manager, whether it's VirtualBox or VMware, should pop up. So this is basically an archived virtual machine. I took one of my virtual machines, I saved it in this file, and you should be able to import it in any VM manager. So you double click that, you can see some of the parameters here. So go ahead and set it up however you want. You don't really need 2 CPUs, you don't really need 2 gigs of RAM, but if you can afford it, go ahead. The objective at the end here is to basically turn this SIFT VM into a router, and then have maybe 1 or 2 other VMs use it as a gateway. So go ahead and allocate whatever memory you think is appropriate. If you only have 4 gigs, then probably maybe 768. If you can afford more, that's always better. For the SIFT workstation, do not click reinitialize the MAC address. Normally you would want to, if you were going to make different instances of the same VM, but because I have some really specific settings, you want to keep this one unchecked. Anything else to know? No, should be okay. So go ahead and set the CPU and RAM to whatever you want, and then hit import. And this will probably take a few minutes or so. And while that's going on, let's go ahead and go with the PowerPoint. So working with virtual machines, looks like most of you guys have done that before, but we'll just go over some basics. Why do we use virtual machines? It makes it easy to experiment. You can try things. If it breaks, then restore it. Really easy with snapshots. They allow the use of multiple operating systems on one machine. So for example, right here, my Mac is running, and it can run Windows VMs, Linux VMs. Todd's got a Linux system, he can run Windows, etc. Really useful for malware, obviously, because you don't want to have to reset up a system every single time malware ruins it. So I use it a lot for malware. You can let the malware run loose, and after it destroys everything, just revert with the snapshot. Also really useful because you can take full memory dumps. You could do that with some utilities as well on host systems, but for malware it's particularly useful because you don't have to use utilities and stuff. You just use your VM manager. Okay, so setting up with VirtualBox, I think you guys know most of this stuff here. This is your main window for VirtualBox. You hit New, and it asks you for the name, what type of OS, and from what I've seen, this isn't really important as long as you get the right 64-bit or 32-bit, and you specify that right here, what version. Memory size, so whatever is appropriate for your system. Creating a virtual hard drive. It's basically a file on your host operating system, and the guest operating system will use that as the hard drive. Alright, and then some configuration, number of processors, go ahead and choose. You can choose up to 8, it looks like, but it's only recommended to choose however many cores, physical CPU cores that you have. So for me, on my i5, that's going to be up to 4. Or maybe I did this on, no, I'm sorry, I did this on my i7 machine, so it has 4 cores, even though it's got 8 through hyper-threading. VTX, so you need this option selected if you're doing 64-bit, and you also need it enabled in your UEFI or the BIOS, so the hardware settings. Okay, and then configuring hard disks. I think you guys know how to do that. Anybody have any questions so far? No, that's good. Okay, and this is what we're mostly interested in today, is the networking. So we've got several different options here. NAT, I think this is the most common. This is where your host machine is going to be the NAT router to the VM. It's going to, your host machine is going to be the gateway. Bridged, the VM and the host use the same network interface card, and both of them get a unique IP address. Okay, internal network, this is where only virtual machines can talk to each other. So they can't talk to the host, and they can't talk out over the internet. And host only, it's like internal network, except you get to talk to the host operating system. And I drew out some diagrams of each of these setups. So this one is NAT. Your virtual machine is inside the host. It has an IP address, and inside the host you have a virtual NAT router, and this is like your wireless card on your laptop. This talks to some router which goes over to the internet. So the main point is that the VM talks through the NAT router right here to get to the internet. Okay, and then bridged adapter. So I drew a dashed line right here because these two are basically the same thing. The VM is using the host's NIC, and it appears, I think this should be a 2. So the main point is that the host and the VM, they both appear as distinct machines on a network. So the VM gets its own address. Yeah, kind of like that. And the VM basically talks directly to the router to get to the internet, so it doesn't go through the host. Alright, and then we have internal network. So the host has its own NIC. It talks to the router to get to the internet. But you can see right here we have 3 virtual machines inside the host. And hey, Brian. And they have a switch. They have their own switch, which is isolated from the rest of the world. So they can talk to each other here, but they can't talk to the host, and they can't get internet access. Alright, and then the next one is host-only adapter. So it's basically like internal networking. The VMs can talk to each other, but the only difference is that they can also talk to the host. So the host creates a virtual network adapter, and I can actually show you that on my terminal. Let's see, so this is my wireless EN1. It has its own IP address, and bridge 0 right here. I think this one is the virtual NIC for VirtualBox. So basically, if I wanted to talk to my internal VMs, it would be through a virtual NIC right here. Okay.
So, the bridges are virtual NIC.
Which one?
You showed the bridge. Is that refers to?
In the terminal?
NIC?
Yeah.
Okay.
Yeah. So VirtualBox creates that virtual NIC so that you can, your VMs can basically talk to your host operating system using that virtual NIC. So yeah, it appears as a networking device on your operating system, on your host operating system. Okay, so this shows the setup page in VirtualBox, and this is basically how you set up a networking device. You enable the adapter, you choose what kind of networking you want, so right here it's internal network, and this name right here, the way it works is if you've got two virtual machines, you would enter the same name right here, and that would put them basically on the same switch. And then promiscuous mode, you can set whether you allow or deny, and then you give it a MAC address.
So if you wanted to use Wireshark on the VM, you'd have to enable promiscuous mode?
If you wanted the machine to be able to listen and accept packets that don't necessarily belong to it, like I guess for broadcasting, I guess Kali, I'm not sure if that matters, but I think it's for when packets are not intended for your router, and if you're on a hub or something, then you can still pick up those packets anyway.
Oh, okay.
Otherwise, it would just ignore it. Serial ports, so these are useful for kernel debugging. We're not really going to use these. USB. So for VirtualBox, we have this USB setting right here, and this is where your filters go. So what a filter does is you enable it for a virtual machine, and anytime you plug it in, it goes directly to that virtual machine, so you don't have to pass it through manually every time you plug it in. And in order to enable USB 2.0, you have to go to the VirtualBox webpage, and they have some extensions. You have to install those extensions to be able to use USB 2.0. Otherwise, it's stuck at 1.1. I'm not sure how that works for VMware. It's probably something similar.
Is it
They might have it built in.
Do you have the same for 3.0?
I don't think they have 3.0 implemented.
Okay.
Not yet. And then shared folders. So this is really useful. You could create a shared folder on your host operating system, and then both operating systems can use it, the host and the VM. And for Linux, you might have to use a command like this to mount it. In Windows, you do it through map network drive. So the demo that we're basically going to be doing today is a router setup. This is how I have my Malware Lab set up at home. I've got my laptop, which is the host. I've got actually two routers. I have one router here on one subnet, and then I have another router in the middle, just so that I can separate the two between malware and my main network. Anyway, so the host operating system, it would be on a subnet like this, and the virtual machines, they would be on their own separate subnet. So they talk on an internal network. So normally these virtual machines would only be able to talk to each other, but I have one router, which you guys copied over, the SIFT workstation. It's set up as a router so that if this router or if this virtual machine wants to talk over the internet, it has to go through the switch to the router, and this router has its own virtual NIC. It's in bridge mode. That talks to the router, goes to the internet, and comes back to go back to this virtual machine. And the reason I do that is because it's helpful to have one system be able to filter out traffic, to be able to sniff traffic and see what's going through. So this is what we're going to be setting up today. Yeah.
So does that mean every time you want to go you want to use VM1 to connect to the internet, you always have to have the router VM1 too?
Yeah, that's right. With this setup at least. You could easily change VM1 to just do NAT or something. But for my malware station, yeah, I want this router to have to be able to see the traffic before it goes out. Alright, so hopefully your SIFT workstation copied over. Might be helpful to take a snapshot. So just call it default snapshot, something like that. And there's a little bit of setup that we have to do. So go to the settings for the SIFT workstation. We need to go to networking. So we see adapter 1. It's got this MAC address, and it's an internal network. And then adapter 2, this is going to be the one that connects the system, connects all the other VMs to the world. And this is a bridged adapter, but let's see, if we're using SJSU Campus, bridged adapter is not going to work because you guys know we have to type in our password, right? You need your student ID and your password. That's the 802.1x setup,
Yeah.
that security. So because of that, we can't use bridged because the VM doesn't know that it's supposed to be talking over 802.1x. I guess we could configure it, but it's going to be easier just to use NAT for right now. So go ahead and set that to NAT. Next thing, shared folders. So this is my shared folder on my malware machine. Obviously you don't have it on your system, so just go ahead and take that out. Alright, then when you're done, hit OK. And go ahead and power that up. So it's going to be a little bit weird because I have my keyboard layout on there. It's Dvorak. So you guys are going to have to log in and then change the change the keyboard layout. So the password is malware, but you're probably going to have to type it in like this: MAP, comma, A, O, MAL, WARD. So you're probably going to have to type that in to get in. So did that work?
Wait, what was the password?
It's malware, but this is the Dvorak translation.
Map AOD.
Map, comma, AOD.
So is this set up for your keyboard thing?
Yeah. So in order to change that, let's see, go to the Ubuntu button, System Settings, Keyboard, Layout Settings, and then add, what are we adding? English US. Yeah, US English. and then take away Dvorak. Then you should be able to type. Okay, so that's our SIFT workstation. Now, if you have another VM, fire that up. But before you do, you have to change the network adapter. Oops. So we're going to make this one an internal network. It should have the same name as the previous machine, so intnet. Okay, go ahead and hit OK once you get that on internal. So does anybody have any questions so far? Everyone's good? Okay, so I don't actually have Kali installed. I'm going to have to use the ISO. Oh, yeah, I have it on the ISO. So live mode. Hello. Okay, this thing's looking for an IP address with DHCP. So go ahead and disable networking in Kali. Is everybody logged in?
Does it have to be copied?
It doesn't have to be, no. It just has to be internal networking.
So you want it to disconnect from this?
Let me see where you are.
Oh, I mean, you said disconnect, right? For the
Did you get an IP address?
multitask, whatever, INET6, IPv6, IP address.
Okay. Alright, so let's see, go to right-click the networking icon, go to Edit Connections, and you should see your connection right there. Go ahead and hit Edit. I guess we can connect automatically. Go to IPv4 settings. We're going to manually set this up. Hit Add, and then let's see, we can do 192.168.64 because that's the subnet that I'm using for my SIFT workstation. .64 dot something, 109 for me. Okay, net mask should be 24 to get it on the right subnet. And then gateway is going to be 192.168.64.1. Okay, and then make sure you hit enter. The thing can be kind of finicky. And then just to make things easy, for a DNS server, just use Google 8.8.8.8. And when you're done, hit save. Okay, everybody caught up? Alright then, open up a terminal, hit ifconfig. Oh, and if you don't have an IP address, it's probably because we have to enable networking. So go ahead and enable that. Alright, why is it not getting an IP?
Mine worked.
That's good. Mine didn't.
I was just saying. Just good.
The net mass change.
Okay, there we go. Okay, so now we have an IP address, and let's try to ping the gateway. So 192.168.64.1. Oh, no good. So we probably have to set up the SIFT workstation, so let's go back to that. Ignore. Okay, if you right-click the networking icon up here, then you can see that the external network connection that is currently connected, internal network is not, so we have to enable that. Okay, so it tells you it's connected. If we do ifconfig, you should see the internal network.
I can't type. Oh, wait, I forgot.
You gotta set your keyboard layout.
Yeah. Keep going.
So you should see the internal network address and then the external network address. So once you enable the networking, go back to Kali or whatever other operating system you're using, and then try to ping it again. And you should see that you get something back this time. So are you guys seeing that? 168.64.1. Got it? Okay. Now if you try to ping, for example, actually, why don't we do this? Let's go back to SIFT and let's open up Wireshark. So in Wireshark, listen on Ethernet 0. This is the internal network. And then if you ping from the other operating system, you should be able to see it there. So let's try that one more time. Yeah, so there's our pings right there. So yeah, so far we've got communication between the two VMs. And if we go to the diagram, so basically we can talk between VM1 and the router VM, but we don't have the external connection. We don't have the WAN connection yet.
I think I missed something in the edit connections part.
Let me take a look. Excuse me.
I thought it's already been
For
configured.
this thing, could you pretty much like ping Google, right?
You should be able to.
Oh, you can.
This right here is SIFT.
Yeah.
So it has two network cards.
Okay.
One on the LAN,
Uh-huh.
the internal LAN, and then one that talks out to the WAN.
So if I wanted to, is it possible to just, let's say you didn't want a router VM, could you just make all the VMs have like two network cards connected internally and to the outside?
Sure. Yeah. Yeah, you can set it up any way you like.
Is there a lot of interference with this?
Interference?
Like interference, because I remember when I opened up my VM routers or my VM adapters, and my internet just like ended. No.
Maybe you misconfigured it somehow. It shouldn't affect anything on your host. Unless you're downloading a lot of stuff and then it slows it down. So were you able to get that?
I think so.
I don't see an IPv4 address. Can you disable it and then enable it again? Yeah, just go ahead and save that. Close that.
Look at Brian, he's sleeping.
Baby.
Something here just to sleep.
Wait, this is recorded, right?
Yeah. We should just point the camera at him.
Can you type
No.
IF
We
config?
should have like when we edit the video, what the picture and what it's show like. It's like
Like,
For-
look at the awesome students. Awesome
This is a
students.
great talk.
INET, 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 and then the IP address.
I thought you had to pay for this VM.
And then
The
space.
fifth one.
Sips? Wasn't that given to us for free during the USCC?
The camp, but otherwise you'd have to pay for it, right?
Yeah.
FF,
So,
So are we legally allowed to share this?
and then 00.
oh shit. Okay, we should not spread this video.
You think? I'm looking at
IF config.
I don't think we were allowed to share it.
Okay, let's go type route, RUT. That's it.
Oh no, you can.
We could? It's free?
Yeah.
Okay, it's fine then.
Wait, okay, can you type route, add, default, GW,
Oh, you have to make an account though.
space,
So we can just ask everyone to make an account right now.
64,
Wait, but
1. And then
yeah, USCC?
try up arrow,
Oh no.
ETH.
Hey, were you at the USDC? What's your name again?
Jabari. Yeah, I'm saying.
Enter.
Yeah, so he's supposed to have it already.
I had it from 2 years ago,
route
but I
to
never
default.
opened up that div ever since.
Was he in the USCC?
Armen?
Oh no, I mean,
And then
No. No.
2 up arrows.
Hmm.
Enter, type route. Okay, level 2. So try to ping the gateway.
Alright, so while we're waiting, I'd like to announce that our website officially launched. You're allowed to go on the website and
You got
do
it.
whatever you want with it. So,
oh really?
yeah. I'll give you guys the link later. It'll be on Facebook.
Website's up. We can hack it, destroy it. I hope
I
you have
know.
backups.
I sent together a message at because I finished at like 12 midnight.
Mhm.
This got running. And Josh freaking texted me 4 in the morning. Hey, I hacked all your shit. Like,
Okay, so now everybody has Kali. Kali able to ping Sift.
I wish. I brought my computer.
wait, that's from. Oh, got it.
Where did Kali go? Here we go. So now try to ping Pokemon.com. My favorite test website.
Command not found.
Oops.
Wait, what interface were we supposed to use on the fifth one for Wi-Fi?
ETH0. So that's the internal. So you try to ping Pokemon.com or whatever your favorite website is, and you should see that it doesn't work because right now we don't really have any connection to the outside world. We're
Mine's
at
working.
We're at this
Pokemon.com. Are you on Sift or Kali?
Probably
Do you have another network card?
it might be.
You might be using another network card.
Oh, working.
Disable it. Disable network card.
So the reason for that, so we can ping the router, but we don't have this router forwarding yet. It's not forwarding packets that it receives from other VMs and sending it back out over the internet. So we got to set that part up. So go back to Sift and cancel Wireshark right now. Sift. So do a sudo vi etc ufw. That's the uncomplicated firewall, which is basically a front end for IP tables, the IP tables firewall. And I put a file in there called router.rules. So everybody got that? And then type in the password. It's just malware. And then you'll see all of the rules that we have set up for this IP tables router.
Well, what's the password?
Malware. Okay, so this line right here, this is something that I added. This is to enable masquerading. Basically, what the router here is doing for my host and other systems on the network, this router VM is going to be doing for the other VMs right here. It's going to perform NAT for these other VMs. Okay. Does everybody know what NAT is, by the way? NAT. So when you're at home, you've got your computer here, maybe your roommates have other computers. You've got your 192.168. You're probably familiar with that IP address.
Yeah.
So this is only internal. This IP address is only internal. Only you and your roommate, your brother, your sister, only you guys can see this. Somebody from the outside is only going to see this router IP address. This is the external IP address. So this router is basically representing everybody behind the router. As another example, we could show what's my IP address. So right here, my IP address locally is 10.189.234.85. That's like being one of these guys right here. And so this is like the router right here. So people from the outside world, they won't be able to connect unless the router delegates those packets and routes it to my internal IP address. Okay. So yeah, that's what we're setting up for the router VM right here. And you can see that's why it has two IP addresses. It's got one to connect to the outside world, which is going to be this virtual NIC, and then it's got another IP address to communicate with the other VMs. Alright, so where were we? What happened to my VM? Here we go. Okay, so we're at our router rules right here. Scroll down and look for a couple comments over here. So this is what I have set up for home. This one right here says, if we talk to somebody from the outside, then let those packets back in. Basically so that other VMs on this internal VM network, so that they can get data back. And then this one right here, this is just to protect my other systems. So we can comment that out. Go ahead and put a pound sign at the beginning of that line. And then this one right here says anything from, let's see, ETH0, this is the external network. ETH1 is the external network. So this is basically just to protect my other systems in my house so that nothing on my malware network can talk to my regular network for my regular systems. So for this line right here, just go ahead and delete everything from the exclamation to the end of the IP address. So it should look like this. So does everybody have that? And I'm going to go ahead and save it. Is everybody up to this point?
Do you have it?
I'm a little behind. I had to install VirtualBox, so I'm just kind of just watching it.
It's hard to follow. I follow.
You should still be able to do it through VMware.
It gave me an error when I tried to install it, so I just ended up installing VirtualBox.
Okay. Maybe we can look at it after this.
Can you explain real quick what the flags mean for the router table?
Which one?
Just the flags in general, like -A and -I and J.
-A, so this says append to the forward chain. That's basically not table, but a group of rules
Okay.
for forwarding.
Okay.
You would have to read up on IP tables.
Okay.
Yes.
So -I, that says input, so the input is going to be traffic coming from the external NIC.
Okay.
-O says packets coming, so they're coming from the external network.
Yeah.
They're trying to come into the virtual machine network, the internal network.
Wait, what was 0 again? Or O?
-O
-O.
for output,
Output. And what was -I?
input.
Okay.
So packets coming from this NIC, which is for the external network, so they're coming from the outside
Internet.
in. And where the destination is
Oh, that's really neat. Okay.
my home router, protocol is UDP and port 53, so accept those. The reason I have this is because I don't want any of my systems communicating to my home router unless it's for DNS, which is basically what they use on port 53 right here. So unless it's port 53 DNS, don't allow any communication. That's what this rule says.
Wait, so what's -J?
-J, jump to accept.
Oh, so just like little. Okay.
Yeah. So we're disabling this because we're not at my house, so we don't need this.
How do you disable?
It's commented out. So
Oh, yeah, I got it.
yeah, anything that
This is code,
starts with a pound is a comment. Okay, so that's saved.
Excuse us.
Hello.
Lola.
Did you create that through a program, through the UFW program, or did you use IP tables to make all those rules?
How did I do that?
Probably IP tables.
I typed those in through IP tables, so something like IP tables -A, blah blah blah,
Yeah.
over here.
Oh wait.
And how did I save it? I can't remember. I did that a long time ago. What if I do IP table save? That's not good.
Just smile.
Yeah, I forgot how to do that, but there's a way that you can save all of the rules and generate a file like that.
Oh.
And since we made that change, we have to override the rule. So sudo IP tables -restore, and the input is going to be that file. So etc ufw router.rules. So go ahead and do that.
So you made each individual rule from that list yourself?
No, just those few that we changed.
Oh, okay. He's like, dang,
Yeah.
we'll take it.
The rest were,
Go weak.
I guess they're generated by Ubuntu.
Oh, okay.
Yeah. I don't know what most of those other ones do. I haven't taken a look at them. Okay, router.rules. Okay, and then we have our network enabled, our network adapter. So now if we go back to Kali, wait a minute, what's the default password?
Tor? T-O-R?
There we go. Okay, ping Pokemon.com.
Oh crap!
So now we have connection to the outside world. And if we open it up in a browser, Pokemon.com, we are at the official Pokemon website. So what's going on is we've got a VM right here, Kali. It goes through the switch, talks to SIFT. SIFT sends it out, the virtual NIC, to the router. Actually, this is NAT. We changed this to NAT. So it goes from the VM to the virtual switch to the router to the virtual NAT router to the router to the internet, and that's your internet connection. And like we were showing before through Wireshark, you can see all of the traffic through Wireshark. Let's go ahead and unfull screen this. Oh, darn, can't put it over there.
I want to see what happens when you keep on that.
Okay, so we can go to, I don't know, what's another good website?
Yu-Gi-Oh.com.
Which one?
Yu-Gi-Oh.com.
Yu-Gi-Oh.com.
It's free Magic. That's the biggest card game.
Okay.
Yu-Gi-Oh's dying now.
It's actually a Yu-Gi-Oh card game, though.
It still works.
Alright. And so you can see all of the traffic over here. Everything from the DNS to HTTP. Yeah, so like I said, I use this setup a lot for one VM. This would be like my malware machine. And if I let it go over the network, then I would be listening with SIFT on this system, just so that I can pick up the traffic. So yeah, a lot of this stuff was pre-configured. For example, there's a setting that you have to set for, what was it? proc/sys net IPv4 IP forward. So this is basically a little file right here, IP forward, and it has a value 0 or 1. By default it's 0, and that means it's not going to allow IP forwarding, and I set it to 1, so that we can use this as a router. So you need to set this up. There's a couple other things that you need to set up, so you guys can look into that on your own time. But yeah, this is basically how you set up Linux to be a router. So any questions?
A lot, but no time to ask them.
All right. Well, you can ask me anytime. We can take care of it after this. All right then. Thank you guys.
Enjoy.